All right, today we're zooming way in, down to the microscopic level, to really get a handle on a major challenge: muscular dystrophy. Our muscles, they pretty much define our movement, right? They power everything we do, from, walking down the street to just breathing. They're basically the engines of our bodies. So, what happens when those engines start to break down? I mean, really break down on a fundamental level. That's the huge question we're going to dig into. So, first things first, before we get into the nitty gritty, we've got to be on the same page. Let's start with a really basic question. What exactly is muscular dystrophy? Okay, this definition right here, it's packed with a few really key ideas. First off, this isn't just one single disease. It's actually a whole group of different disorders. That's super important. Second, they're all genetic. They start with your DNA. And third, they're progressive, which is just another way of saying they get worse over time. And it all boils down to defects in the tiny proteins that are supposed to build and maintain our muscles.
And here's what that looks like over the long haul. As those really important muscle fibers start to break down and die off, the body tries to patch things up. But here's the problem. It doesn't replace them with new, healthy muscle. Instead, it fills in the gaps with fat and a kind of fibrous, scar-like tissue. And that stuff, well, it can't contract. It can't generate force. And that's exactly where the loss of strength comes from.
Okay, so we've got the what down. We know what happens on a big picture level. But now let's talk about the how. We're going to zoom way, way in, right down to the cellular level, to actually see this microscopic breakdown as it happens. I love this analogy. It makes so much sense. Think about a big concrete pillar. The concrete is like the muscle itself, right? But what really gives it strength, what stops it from just crumbling under pressure, it's the steel rebar inside. Well, in our muscles, we have a protein system called the dystrophin glycoprotein complex, and it does the exact same job as that rebar. It reinforces the muscle fibers every time they contract. Now, in many types of muscular dystrophy, that rebar, it's either totally broken or it's just not there at all. And that missing rebar sets off this devastating chain of events. It's like a series of dominoes. Step one, it all starts with a genetic mutation. That one tiny error in the code leads to step two, protein failure. Basically, the rebar breaks, and without that vital reinforcement, what happens? Step three, the muscle fiber itself gets damaged every single time it contracts. And finally, as those fibers wear out and break down, they're replaced by that fat and scar tissue we talked about. It's a cascade, and it leads directly to that progressive weakness. So let's pull back from the microscope now. How does all this microscopic damage actually show up in the real world, on a person's body? What are the signs and symptoms we can actually see? Well, across most of the different types of MD, you start to see a really common pattern. It's that progressive muscle weakness, for sure, and a visible loss of muscle mass. But what does that mean in real life? It means everyday things become a huge challenge. Walking, climbing a flight of stairs, even something as simple as getting up from the floor. You might also see a particular kind of waddling walk, and sadly, frequent falls become a really serious risk. Okay, so we have a list of symptoms, but what does this really look like, day in and day out? And maybe more importantly, is it only about the muscles that help us walk and move around? Does it stop there? The answer is a big, resounding no. And this is so important to understand. Depending on the exact type of MD, the effects can go way beyond just your arms and legs. This disease can weaken the heart muscle. That's a condition called cardiomyopathy. It can affect the muscles you need to breathe, causing respiratory weakness. It can even impact the GI system, the endocrine system. It's not just a muscle disease. It can be a full-body systemic challenge. All right, let's zoom back out again for a second. We touched on this at the beginning, but it's worth saying again because it's so important. Muscular dystrophy is not just one disease. Think of it more like a big, diverse family of conditions. And this right here is a perfect example of what I mean. Check this out. Duchenne and Becker muscular dystrophy, they're both caused by mutations on the exact same gene, but the results? Totally different. Duchenne, or DMD, is the most common and also the most severe form. It usually shows up in early childhood. But Becker, or BMD, it's a lot milder. The symptoms might not even pop up until someone's a teenager or even an adult. It's just an amazing illustration of how different little errors in the genetic code can lead to this huge spectrum of outcomes. And believe me, the list doesn't stop there. You've got other types like Emery-Dreifuss, limb-girdle, myotonic dystrophy. I mean, the list goes on. Each one has its own unique fingerprints, different symptoms, different muscles affected, different speeds of progression. It's a really, really complex group of diseases. Okay, so we've talked about the definition, we've gone deep on the microscopic mechanism, we've looked at the different types. So what's the big takeaway here? Why does all this detail actually matter? Honestly, if you only remember one single thing from our whole chat today, let it be this sentence. This is the whole enchilada. It connects all the dots. Muscular dystrophies starts with genetic defects in muscle proteins. That leads to the progressive breakdown of muscle fibers, and that results in worsening weakness and loss of mobility. Boom, the entire story right there. And that really brings us to our final thought. Now that we can actually picture that broken rebar inside the muscle, right, the whole challenge just becomes so much clearer. So the question I really want to leave you with is this. Now that we get it, now that we have this deep microscopic understanding, how can we use this knowledge to empower ourselves, to develop better treatments, and maybe just as importantly, to create better, more meaningful support for everyone affected by muscular dystrophy?